Okay, here's our topic. All right. Here's some important information in case you need it. All right. And here's our objective. And what this objective means is if uh, I know first order, what does this order mean? If I know a reaction is first order with respect to a certain reactant, what does that mean? First order means the rate's going to double if the concentration doubles, but we're going to go over in general what that means. All right. We're going to talk about babysitting. Um, on Monday night, Dr. Square babysat a cat, and he commented to his friends that there was a ton of work, a lot of work. And then the next night, he babysat three cats, but it was the same amount of work. All right. Now you'll notice here that the amount of cats is increasing, but the amount of work is relatively constant. This is what we're going to know is going to see as zero order, where you change the concentration and the rate doesn't change. On Wednesday, he babysat a dragon. All right. It was a lot of work, as you can expect. Then the next night he babysat a two dragons, and the work doubled. This is first order. You double the concentration, and the rate doubles. In this case, it's the work that's doubling, but it's the same kind of idea. Friday night he babysat a dog, and as you can, this dog was a good dog, easy to take care of. Had I put that dog in there, this dog over here, Eliza, I don't know if Dr. Square would have been so lucky. Um, so the next night, he babysat two dogs, and it was even less work. This is what is known as negative order, where whatever the reactant is making it the amount of the rate the work go down or the rate of the reaction go down. Um, be kind of uncommon, but they do exist. All right. So here are the trends. Amount of cats going up, the work staying the same. That's zero order. The amount of things go up. What happens here? The work goes up. This is going to be first or second order. This is a positive relationship. And when the work goes down, that's a negative order. All right. So here's what order means for rate law. All right. A value that expresses how a concentration affects affects rate. Zero order we talked about has no effect, whereas the now the order can be it's going to be a positive or negative integer. Mainly the most common in AP is zero, first, or second. Positives, these are first and second orders, they directly affect, meaning they increase it. A negative would make it decrease. Now, if it's a non-integer like a half, it's those they do exist, but those are a little um, rarer. All right, and their effect is a little more complicated. But first order and second order, first order, if you double the concentration, the rate doubles. And second order is if you double the concentration, the rate quadruples. So let's look at some examples. If I had some people in a room and I had a door to get out, or not a door, but this is a turnstile, and sometime later, five people left, so this is an hour, that means the rate is five people per hour. All right. And sometime later, there's five people left. You'll notice it was 6 hours, 30 people. So it's still still five people per hour, these turnstiles. So we're decreasing the rate, or excuse me, the concentration and the rates staying the same. So this is zero order. Um, Typically, we think of these things in terms of increasing the concentrations. Like, how does it affect the rate? You could think of it the other way. So zero order, it doesn't affect the concentration, the rate. The changing concentrations don't affect rate. Now, here you got 40 people in a room, and in this thing here, this thing is a turnstile or a revolving door, not a turnstile. An hour later, you've got only 20 people left. All right. So half of the people left. And then 2 hours later, I only got five. This is classic first order. All right. Because the rate's going down, the concentration is going down, and the rate's going down simultaneously in a kind of like a one-to-one relationship. Um, in this scenario, it's rates half of how much you've got left per hour are going to leave. This is classic first order. Radioactive decay is an example. Typically, though, we think of these as you doubling the concentration, doubling the rate. All right. And the final one is I've got an archway, and I put 4,000 people in this room, and it went down to 2,400. And then 1 hour later, 1,824. So the first, you'll notice the amount of people leaving is decreasing exponentially. This is second order, where you're you're decreasing the concentration and the rate's decreasing twofold. Um, or you double the concentration and the rate uh, goes up by quadruple. All right. All right. Thank you so much. Let me know how I can help. All right. Bye.